Hello all, welcome back to Code Hub. Today let us solve the Lead Codes daily challenge, the minimum average difference. You are given a zero index integer array nums of length n. The average difference of the index I is the absolute difference between the average of the first I plus 1 elements of nums and the average of the last n minus I minus 1 elements. So both averages should be rounded down to the nearest integer. Return the index with the minimum average difference. If there are multiple such indices, return the smallest one. So note the absolute difference of two numbers is the absolute value of the difference. The average of n elements is the sum of n elements divided by n. So the average of 0 elements is considered to be 0. So what does that mean? Let us see the examples to get a understanding. So 2, 5, 3, 9, 5, 3. This is the array that is given in example 1. So the average difference of index 0 is nothing but 2 by 1 minus absolute difference 5 plus 3 plus 9 plus 5 plus 3 divided by 5. So which is nothing but 3. So if we want to calculate the average the difference between this if we want to calculate the average difference of one first index, which is nothing but we will be taking the first two elements and then the first two elements sum divided by 2 and then the next remaining four elements divided by 4. So we will be seeing their absolute difference, which is nothing but 5 plus 2 divided by 7 by 2, which is 3 minus 6 11 20 by 4, which is 5. So if we take an absolute difference between them, it is nothing but 2. So this is absolute difference for when we consider the first two elements. If we want to consider the first three elements, what we can do is that the first three elements we can say it as 5 plus 3 plus 2, which is nothing but 8 plus 2 10, and the next 10 by 3, which is 3, 10 by 3, which is 3, minus 9 plus 3, 9 plus 5, 14 plus 3, 17, 17 by 3, which is wait a second, yeah, 10 by 3 and 17 by 3, which is nothing but 5. So the absolute difference if we take is then it is nothing but 2 again. And if we consider the first four elements and then the next two elements, the first four elements sum is nothing but uh, uh, 19 by 4 is 19 by 4 is 4, and the last two elements sum is 5 plus 3 8 by 2, which is 4. So if we take the absolute difference between the left sum and the right sum, it is nothing but 0. So as you can see that if we can calculate for each and every index I, then the absolute difference is 0, which is the minimum possible thing. And where do we get this? We get this at the index 3, which is nothing but 9. So we have to return the index where we get the minimum absolute difference, average absolute difference, which is nothing but 0 1 2 3. So the answer is 3 here. So this is the problem. So obviously what we can do is for each and every index we can calculate their left sum and we can calculate their right sum and divided by their number of elements. But this is a brute force approach and the time complexity for this solution will be an order of n square. So can we do this better? Definitely we can do this better. We can calculate a prefix sum and a suffix sum. Prefix sum and suffix sum in the sense we can first calculate the total sum. Total sum is nothing but 2 7 10 19 19 24 27. So the total sum here is 27, and we have n is nothing but n is nothing but 6. So we have sum and n. So for each time we can run a left sum. Left sum we can just calculate on the go by traversing from left side. So we can have left sum initially 0. So for each iteration we can calculate left sum plus equals to nums of I. And when we add this current element to the left sum, we can calculate our right sum. Right sum is nothing but sum minus equals to nums of I. So now we have the left sum and the right sum. Left sum is 2 and right sum is nothing but 25. 5, 10, 19, 19 plus 6, 25. So this the right sum is 25 and our left sum is 2. So now we can just calculate easily, very easily, how we can calculate the absolute difference. So the average absolute difference is nothing but left sum divided by I plus 1. So this will be our difference for the left. This will be by average for my left sum, and for my right sum it is nothing but sum divided by n minus I minus 1. N is 6, 6 minus 0, 0 minus 1, which is 5. So hope you understand the logic and the calculation. So by this we can find the difference. If we find the absolute difference, we can calculate the index. So this is what we are going to code. First we can code the approach now. So the time complexity here will be reduced to order of n. So we can have an int answer index. Answer index to be initially 0, and let us have the absolute difference. Let us have the min difference to be initially int max. So first we want to calculate the right sum. Right sum is nothing but the total sum of the array. For auto ampersand num in my nums, right sum plus equals to num. So now we have the right sum, and by the way we can declare the left sum as well. Now for each and every index, for int I equals to 0, we can take the size of the array as well, nums dot size. I equals to 0, I less than n, I plus plus. For each and every time we are going to calculate the left sum is nothing but nums of I, and right sum minus equals to nums of I. Now we have the left sum and the right sum. So now we want to calculate the difference. Int average difference is nothing but left sum divided by I plus 1 minus the right sum divided by n minus I minus 1. That is what they have given. For this we have to take the absolute difference. So now we have the absolute difference between them. Once we have the absolute difference, then we have to check whether this average difference is lesser than the min difference. If this is lesser than the min difference, then my min difference will be get updated with the average difference, and my answer index will be updated with I. And finally returning the answer index. Hope you understand the approach. Now let us submit the code. We have to check for a division by 0 error as well. Right, actually it is right. How we can check the division by 0 is nothing but if n, we can say it as int, we can have two variables, int left average and right average. Int left average, and right average. So left average is nothing but this value, left sum divided by I plus 1. I plus 1, yeah, I plus 1 is definitely not going to be 0 at all. So I plus 1 is definitely not going to be 0 at all. So we want to check for the right sum alone. So we can do like this. We can take this left sum now. And my right average is nothing but if my n minus I minus 1 is equals to 0, then I will store 0, else I will do this division, right sum divided by n minus I minus 1. So now we can just substitute this left average minus the right average. So now we have the difference. Now that there should not be any zero error, division by zero error. Okay, great, it works out. In the left sum, we obviously we prevalent it is prevalent that we did not encounter any division by zero, but in right average calculation we definitely have a division by zero error, so we can just omit that. Now let us submit the code. It should work. What we can so okay, we get an error. Yeah, it is the integer overflow error, so we can have it as long. Let us have everything to be long. Now let us submit the code. Oh, it is funnier that I have encountered the same error previously as well when I solved this problem. Okay, great. Hope you like the solution. Let me know in the comments if there are any suggestions. Let us see in tomorrow's Lead Code Daily Challenge. Until then, bye.